This handbook describes the various environmental conditions affecting human survival and describes isolated personnel, activities necessary to survive during successful evasion or isolating events leading to successful recovery. It is the fundamental reference document providing guidance for any USAF service member who has the potential to become isolated. Deviations require sound judgment and careful consideration. This publication provides considerations to be used in planning and execution for effective mission accomplishment of formal USAF survival, evasion, resistance, and escape, SERE, training, environmentally specific SERE training, and combat survival continuation training programs. The tactics, techniques, and procedures in this publication are recognized best practices presenting a solid foundation to assist USAF service members to maintain life and return with honor from isolating events. Fire is used for warmth, light, drying clothes, signaling, making tools, cooking, and water purification. When using fire for warmth, the body uses fewer calories for heat and consequently requires less food. Having a fire to sit by can also be used as a morale booster. Also, smoke from a fire can be used to discourage insects. Avoid building a very large fire. Small fires require less fuel, are easier to control, and their heat can be concentrated. Never leave a fire unattended unless it is banked or contained. Banking a fire is done by scraping cold ashes and dry earth onto the fire, leaving enough air coming through the dirt at the top to keep the fuel smoldering. This will keep the fire safe and allow it to be rekindled from the saved coals. The three essential elements for successful fire building are fuel, heat, and oxygen. These combined elements are referred to as the fire triangle. By limiting fuel, only a small fire is produced. If the fire is not fed properly, there can be too much or too little fire. Fresh cut, or green fuel is difficult to ignite, and the fire must be burning well before it is used for fuel. Heat and oxygen must be accessible to ignite any fuel. The IP must take time and prepare well. Preparing all of the stages of fuel and all of the parts of the fire starting apparatus is the key. To be successful at Firecraft, preparation, practice, and patience are required by the fire builder. The fuels used in building a fire normally fall into three categories relating to their size and flash point: tinder, kindling, and fuel. Tinder is any type of small material having a low flash point. It is easily ignited with a minimum of heat, such as from a spark. Tinder must be arranged to allow air, oxygen, between the hair-like, bone-dry fibers. The preparation of tinder for fire is one of the most important parts of Firecraft. Dry tinder is so critical that a potential IP should keep it available at all times. It may be necessary to have 2 or 3 stages of tinder to get the flame to a useful size. Examples of tinder include the shredded bark from some trees and bushes, such as cedar, birch bark, or palm fiber. Crushed fibers from dead plants. Fine, dry wood shavings and straw, grasses. Resinous sawdust. Very fine pitch wood shavings, resinous wood, fat lighter, from pine or sappy conifers. Bird or rodent nest linings. Seed down, milkweed, cattail, thistle. Tarred cloth. Cotton balls or lint. Steel wool. Dry powdered sap from the pine tree family, also known as pitch. Paper. Foam rubber. Kindling is the next larger stage of fuel material. Kindling should also have a high combustible point. It is added to, or arranged over, the tinder in such a way that it ignites when the flame from the tinder reaches it. Kindling is used to bring the burning temperature up to the point where larger and less combustible fuel material can be used. Examples of kindling include dead dry small twigs or plant fibers. Dead dry thinly shaved pieces of wood, bamboo, or cane. Always split bamboo as sections can explode. Coniferous seed cones and needles. Squaw wood from the underside of coniferous trees. Dead, small branches next to the ground sheltered by the upper live part of the tree. Pieces of wood removed from the insides of larger pieces. Some plastics such as the spoon from an in-flight ration. Wood which had been soaked or doused with flammable materials, that is, wax, insect repellent, petroleum fuels, and oil. Strips of petroleum gauze from a first aid kit. Dry split wood burns readily because it is drier inside. Also, the angular portions of the wood burn easier than the bark-covered round pieces because it exposes more surfaces to the flame. The splitting of all fuels will cause them to burn more readily. Fuel, unlike tinder and kindling, does not have to be kept completely dry as long as the fire is well established to dry the wet fuel prior to burning. It is recommended that all fine materials be protected from moisture to prevent excessive smoke production. Highly flammable liquids should not be poured on an existing fire. Even a smoldering fire can cause the liquids to explode and cause serious burns. The type of fuel used will determine the amount of heat and light the fire will produce. Dry split hardwood trees, oak, hickory, ash, are less likely to produce excessive smoke and will usually provide more heat than soft woods. They may also be more difficult to break into usable sizes. Pine and other conifers are fast-burning and produce smoke unless a large flame is maintained. Rotten wood is of little value since it smolders and smokes. The weather plays an important role when selecting fuel. Standing or leaning wood is usually dry inside even if it is raining. In tropical areas, avoid selecting wood from trees that grow in swampy areas or those covered with mosses. Tropical softwoods are not usually a good fuel source. Trial and error is sometimes the best method to determine which fuel is best. After identifying the burning properties of available fuel, a selection can be made of the type needed. Recommended fuel sources include dry standing deadwood and dry dead branches, those that snap when broken. Deadwood is easy to split and break. It can be pounded on a rock or wedged between other objects and bent until it breaks. The inside of fallen trees and large branches may be dry even if the outside is wet. The heartwood is usually the last straw. As a last resort, greenwood which can be made to burn is found almost anywhere, if finely split and mixed evenly with dry dead wood. In treeless areas, other natural fuels can be found. Dry grasses can be twisted into bunches. Dead cactus and other plants are available in deserts. Dry peat moss can be found along the surface of undercut stream banks. Dried animal dung, animal fats, and sometimes even coal can be found on the surface. Oil-impregnated sand can also be used when available. Fire site preparation. The location of a fire should be carefully selected. Locate and prepare the fire carefully. After a site is located, twigs, moss, grass, or duff should be cleaned away and scraped to bare soil if possible. If the fire must be built on snow, ice, or wet ground, IP should build a platform of green logs or rocks. Beware of wet or porous rocks, they may explode when heated. There is no need to dig a hole or make a circle of rocks in preparation for fire building. Rocks may be placed in a circle and filled with dirt, sand, or gravel to raise the fire above the moisture from wet ground. The purpose of these rocks is to hold the platform only. To get the most warmth from the fire, it should be built against a rock or log reflector. This will direct the heat into the shelter. Cooking fires can be walled by logs or stones. This will provide a platform for cooking utensils and serve as a windbreak to help keep the heat confined. After preparing the fire, all materials should be placed together and arranged by size, tinder, kindling, and fuel. As a rule of thumb, IP should have 3 times the amount of tinder and kindling than is necessary for one fire. It is to their advantage to have too much than not enough. Having plenty of material on hand will prevent the possibility of the fire going out while additional material is gathered. Conserve matches by only using them on properly prepared fires. They should never be used to light cigarettes or for starting unnecessary fires. Keep some dry tinder in a waterproof container. Tinder should be exposed to the sun on dry days. Adding a little powdered charcoal will improve its ability to burn. Cotton cloth is good tinder, especially if scorched or charred. It works well with a magnifying glass or flint and steel. Fire making can be a difficult job in an Arctic environment. The main problem is the availability of fire-making materials. Making a fire starts well before the match is lit. The fire must be protected from the wind. In wooded areas, standing timber and brush usually make a good windbreak, but in open areas, some type of windbreak may have to be constructed. A row of snow blocks, the shelter of a ridge, or a pile of brush will work as a windbreak. The windbreak must be high enough to shield the fire from the wind, and it can also act as a heat reflector if it is of solid material. A platform will be required to prevent the fire from melting down through the deep snow and extinguishing it. A platform is also needed if the ground is moist or swampy. The platform can be made of green logs, metal, or any material that will not burn through very readily. Care must be taken when selecting an area for fire building. If the area has a large accumulation of humus material or peat, a platform is needed to avoid igniting the material, as it will tend to smolder long after the flames of the fire are extinguished. A smoldering peat fire is almost impossible to put out and may burn for years. The ignition source used to ignite the fire must be quick and easily operated with hand protection such as mittens. Any number of devices will work well: matches, candle, lighter, fire starter, metal matches, etc. IP should arrange a small amount of kindling in a low pyramid, close enough together so flames can jump from one piece to another. A small opening should be left for lighting and air circulation. Matches can be conserved by using a shave or feather stick, or by using a loosely tied fagot or bundle of thin, dry twigs. The match must be shielded from wind while igniting the shave stick. The stick can then be applied to the lower windward side of the kindling. Small pieces of wood or other fuel can be laid gently on the kindling before lighting, or can be added as the kindling begins to burn. The IP can then place smaller pieces first, adding larger pieces of fuel as the fire begins to burn. To avoid smothering the fire by crushing the kindling with heavy wood, IP should use a soda can diameter brace to lean the additional fuel against. This will ensure adequate ventilation of the fire. IP only have a limited number of matches or other instant fire starting devices. In a long-term situation, they should use these devices sparingly or carry fire with them when possible. Many primitive cultures carry fire bundles, by using dry punk or fibrous barks, cedar, encased in a bark. Others use torches. Natural fire bundles also work well for holding the fire. The amount of oxygen must be just enough to keep the coals inside the dry punk burning slowly. This requires constant vigilance to control the rate of the burning process. The natural fire bundle is constructed in a cross-section as shown. A supply of matches, lighters, and other such devices will only last a limited time. Once the supply is depleted, they cannot be used again. If possible, before the need arises, IP should become skilled at starting fires with more primitive means, such as friction, heat, or a sparking device. It is essential that they continually practice these procedures. The need to start a fire may arise at the most inopportune times. One of the greatest aids an IP can have for rapid fire starting is the tinderbox previously mentioned. Using friction, heat, and sparks are very reliable methods for those who use them on a regular basis. Therefore, an IP must practice these methods. IP must be aware of the problems associated with the use of primitive heat sources. If the humidity is high in the immediate area, a fire may be difficult to ignite even if all other conditions are favorable. For primitive methods to be successful, the materials must be bone dry. Preparation, practice, and patience in the use of primitive fire building techniques cannot be overemphasized. A key point in all primitive methods is to ensure that the tinder is not disturbed. Flint and steel is one way to produce fire without matches. To use this method, IP must hold a piece of flint in one hand above the tinder, grasp the steel in the other hand and strike the flint with the edge of the steel in a downward glancing blow. True flint is not necessary to produce sparks. Iron pyrite and quartz will also give off sparks even if they are struck against each other. Check the area and select the best spark-producing stone as a backup for the available matches. The sparks must fall on the tinder and then be blown or fanned to produce a coal and subsequent flame. Flint, such as the so-called metal match, consists of the same type material used for flints in commercial cigarette lighters. Some contain magnesium which can be scraped into tinder and into which the spark is struck. The residue from the match burns hot and fast and will compensate for some moisture in tinder. If issued survival kits do not contain this item and the IP choose to make one rather than buy it, lighter flints can be glued into a groove in a small piece of wood or plastic. The IP can then practice striking a spark by scratching the flint with a knife blade. A 90-degree angle between the blade and flint works best. The device must be held close enough for the sparks to hit the tinder, but enough distance must be allowed to avoid accidentally extinguishing the fire. Cotton balls dipped in petroleum jelly make excellent tinder with flint and steel. When the tinder ignites, additional tinder, kindling, and fuel can be added. Note: care should be taken to protect synthetic flint from water, and especially salt water. Another method of producing fire is to use the battery of the aircraft, vehicle, storage batteries, AA, C, D, CR123, etc. using two insulated wires. Connect one end of a wire to the positive post of the battery and the end of the other wire to the negative post. Touch the two remaining ends to the ends of a piece of non-insulated wire. This will cause a short in the electrical circuit and the non-insulated wire will begin to glow and get hot. Material coming into contact with this hot wire will ignite. IP should use caution when attempting to start a fire with a battery. They should ensure that sparks or flames are not produced near the battery because explosive hydrogen gas may be produced and can result in serious injury. If fine-grade steel wool is available, a fire may be started by stretching it between the positive and negative posts until the wire itself makes a red coal. If IP have sunlight and a burning glass, a fire can be started with very little physical effort. Concentrate the rays of the sun on tinder by using the lens of a lensatic compass, a camera lens, or the lens of a flashlight which magnifies. Even a convex piece of bottle glass may work. Hold the lens so that the brightest and smallest spot of concentrated light falls on the tinder. Once a wisp of smoke is produced, the tinder should be fanned or blown upon until the smoking coal becomes a flame. Powdered charcoal in the tinder will decrease the ignition time. Add kindling carefully as in any other type of fire. Practice will reduce the time it takes to light the tinder. A flashlight reflector can also be used to start a fire. Figure 14.8. Place the tinder in the center of the reflector where the bulb is usually located. Push it up from the back of the hole until the hottest light is concentrated on the end and smoke results. If a cigarette is available, use it as tinder for this method. The bamboo fire saw is constructed from a section of dry bamboo with both end joints cut off. The section of bamboo, about 12 inches in length, is split in half lengthwise. The inner wall of one of the halves, called the running board, is scraped or shaved thin. This is done in the middle of the running board. A notch to serve as a guide is cut in the outer sheath opposite the scraped area of the inner wall. This notch runs across the running board at a 90-degree angle. The other half of the bamboo joint is further split in half lengthwise, and one of the resultant quarters is used as a baseboard. One edge of the baseboard is shaved down to make a tapered cutting edge. The baseboard is then firmly secured with the cutting edge up. This may be done by staking it to the ground in any manner which does not allow it to move. Tinder is made by scraping the outer sheath of the remaining quarter piece of the bamboo section. The scrapings, approximately a large handful, are then rubbed between the palms of the hands until all of the wood fibers are broken down and dust-like material no longer falls from the tinder. The ball of scrapings is then fluffed to allow maximum circulation of oxygen through the mass. The finely shredded and fluffed tinder is placed in the running board directly over the shaved area, opposite the outside notch. Thin strips of bamboo should be placed lengthwise in the running board to hold the tinder in place. These strips are held stationary by the hands when grasping the ends of the running board. A long, very thin sliver of bamboo, called the pick, should be prepared for future use. One end of the running board is grasped in each hand, making sure the thin strips of bamboo are held securely in place. The running board is placed over the baseboard at a right angle, so that the cutting edge of the baseboard fits into the notch in the outer sheath of the running board. The running board is then slid back and forth as rapidly as possible over the cutting edge of the baseboard, with sufficient downward pressure to ensure enough friction to produce heat. As billows of smoke rise from the tinder, the running board is picked up. The pick is used to push the glowing embers from the bottom of the running board into the mass of tinder. While the embers are being pushed into the tinder, they were gently blown upon until the tinder bursts into flame. When the tinder bursts into flame, slowly add kindling in small pieces to avoid smothering the fire. Fuel is gradually added to produce the desired size fire. If the tinder is removed from the running board as soon as it flames, the running board can be reused by cutting a notch in the outer sheath next to the original notch and directly under the scraped area of the inner wall. This is a friction method which has been used successfully for thousands of years. A spindle of yucca, elm, basswood, or any other straight grain wood, not softwood, should be made. The IP should make sure that the wood is not too hard or it will create a glazed surface when friction is applied. The spindle should be 12 to 18 inches long and 3/4 inch in diameter. The sides should be octagonal, rather than round, to help create friction when spinning. Round one end and work the other end into a blunt point. The round end goes to the top upon which the socket is placed. The socket is made from a piece of hardwood large enough to hold comfortably in the palm of the hand with the curved part up and the flat side down to hold the top of the spindle. Carve or drill a hole in this side and make it smooth so it will not cause undue friction and heat production. Grease or soap can be placed in this hole to prevent friction. The bow is made from a stiff branch about 3 feet long and about 1 inch in diameter. This piece should have sufficient flexibility to bend. It is similar to a bow used to shoot arrows. Tie a piece of suspension line or leather thong to both ends so that it has the same tension as that of a bow. There should be enough tension for the spindle to twist comfortably. The fireboard is made of the softwood and is about 12 inches long, 3/4 inch thick, and 3 to 6 inches wide. A small hollow should be carved in the fireboard. A V-shaped cut can then be made in from the edge of the board. This V shape should extend into the center of the hollow where the spindle will make the hollow deeper. The object of this V cut is to create an angle which cuts off the edge of the spindle as it gets hot and turns to charcoal dust. This is the critical part of the fireboard and must be held steady during the operation of spinning the spindle. While kneeling on one knee, the other foot can be placed on the fireboard and the tinder placed under the fireboard just beneath the V cut. Care should be taken to avoid crushing the tinder under the fireboard. Space can be obtained by using a small, 3/4 inch diameter stick to hold up the fireboard. This will allow air into the tinder where the hot powder, spindle charcoal dust, is collected. The bowstring should be twisted once around the spindle. The spindle can then be placed upright into the spindle hollow socket. The IP may press the socket down on the spindle and fireboard. The entire apparatus must be held steady with the hand on the socket braced against the leg or knee. The spindle should begin spinning with long even slow strokes of the bow until heavy smoke is produced. The spinning should become faster until the smoke is very thick. At this point, hot powder that can be blown into a glowing ember has been successfully produced. The bow and spindle can then be removed from the fireboard and the tinder can be placed next to the glowing ember, making sure not to extinguish it. The tinder must then be rolled gently round the burning ember, and blow into the embers, starting the tinder to burn. This part of the fire is most critical and should be done with care and planning. The burning tinder is then placed into the waiting fire lake containing more tinder and small kindling. At no time in this process should the IP break concentration or change sequence. The successful use of these primitive methods of fire starting will require a great deal of patience. Success demands dedication and practice. The fire thong, another friction method, is used in only those tropical regions where rattan is found. The system is simple and consists of a twisted rattan thong or other strong plant fiber, 4 to 6 feet long, less than 1 inch in diameter, and a 4-foot length of dry wood which is softer than rattan, deciduous wood. Rub with a steady but increasing rhythm. A variation of this would be to use a wire as your thong. As the wire is pulled back and forth across the length of wood, it will get hot with friction. Once hot, the wire can be applied to accelerants such as liquid fuel or gunpowder from an issued bullet. To work best, mix accelerant with another, More traditional tinder, the night end of the day-night flare can be used as a fire starter. To work effectively, the flare should be used as it is starting to burn out rather than at the start of the ignition. Using the flare at the start of the ignition cycle will quickly expend available fuel due to the extreme heat and exhaust of the flare. Additionally, IP must weigh the importance of a fire against the loss of a night flare. Some emergency kits contain small fire starters, cans of special fuels, windproof matches, and other aids. IP should save the fire starters for use in extreme cold and damp, moist weather conditions. Plastic items may be the type that burn readily. As an example, plastic spoon handles can be pushed deep enough into the ground to support the spoon in an upright position. Light the tip of the spoon. It will burn for about 10 minutes, long enough to dry out and ignite small tinder and kindling. If a candle is available, it should be ignited to start a fire and thus prevent using more than one match. As soon as the fire is burning, the candle can be extinguished and saved for future use. If a candle is packed in a personal survival kit, PSA, the wick should be prepped prior to packing. Tinder can be made more combustible by adding a few drops of flammable fuel material. An example of this would be mixing the powder from an ammunition cartridge with the tinder. After preparing tinder in this manner, it should be stored in a waterproof container for future use. Care must be used in handling this mixture because the flash at ignition could burn the skin and clothing. IP can improvise the stove from a container and burn either refined petroleum products or rendered animal fats for fuel. Animal fat can be rendered through heating to produce flammable oil. Refined petroleum or rendered animal fat oil can be collected in a container and an improvised wick placed in it. When this is lit, it will provide both heat and light for the IP. On barren lands in the Arctic, fuel may be the only materials IP have available for fire. A stove can be improvised to burn fuel, lubricating oil, or a mixture of both. The IP should place 1 or 2 inches of sand or fine gravel in the bottom of a can or other container and add fuel. Care should be used when lighting the fuel because it may explode. Slots should be cut into the top of the can to let flame and smoke out, and holes punched just above the level of the sand to provide a draft. A mixture of fuel and oil will make the fire burn longer. If there is not a can available, a hole can be dug and filled with sand. Fuel is then poured on the sand and ignited. The IP should not allow the fuel to collect in puddles. Lubricating oil can be burned as fuel by using a wick arrangement. The wick can be made of string, rope, rag, sphagnum moss, or even a cigarette end should be placed on the edge of a receptacle filled with oil. Rags, paper, wood, or other fuel can be soaked in oil and thrown on the fire. A stove can be made of any empty wax carton by cutting off one end and punching a hole in each side near the unopened end. IP can stand the carton on the closed end and loosely place the fuel inside the carton. The stove can then be lit using fuel material left hanging over the end. The stove will burn from the top down. Sealed blubber makes a satisfactory fire without a container if gasoline or heat tablets are available to provide an initial hot flame. The heat source should be ignited on the raw side of the blubber while the fur side is on the ice. A square foot of blubber burns for several hours. Once the blubber catches fire, the heat tablets can be recovered. Eskimos light a small piece of blubber and use it to kindle increasingly larger pieces. The smoke from the blubber fire is dirty, black, and heavy and will penetrate clothing and blacken the skin, but the flame is very bright and can be seen for several miles. Most fires are built to meet specific needs or uses, either heat, light, or preparing food and water. The following configurations are the most commonly used for fires and serve one or more needs. The teepee fire can be used as a light source and has a concentrated heat point directly above the apex of the teepee, which is ideal for boiling water. To build a teepee fire, place a large handful of tinder on the ground in the middle of the fire site, push a stick into the ground slanting over the tinder, and then lean a circle of kindling sticks against the slanting stick, like a teepee, with an opening toward the windward side for draft. To light the fire, crouch in front of the fire laying with your back to the wind and use an ignition source to light the tinder. Feed the fire from the downwind side, first with thin pieces of kindling, then gradually with thicker pieces of fuel, creating a teepee shape of fuel above the burning kindling. Continue feeding until the fire has reached the desired size. The teepee fire has one big drawback: it tends to fall over easily. However, it serves as an excellent starter fire. As the name implies, this sleigh looks similar to a log cabin. Log cabin fires give off a great amount of light and heat primarily because of the amount of oxygen which enters the fire. The log cabin fire creates a quick and large bed of coals and can be used for cooking or as the basis for a signal fire. The long fire begins as a trench, the length of which is laid to take advantage of existing wind. The long fire can also be built above ground by using two parallel green logs to hold the coals together. These logs should be at least 6 inches in diameter and situated so the cooking utensils will rest upon the logs. 2 1-inch thick sticks can be placed under both logs, one at each end of the long fire. This is done to allow the coals to receive more air. A pyramid fire looks similar to a log cabin fire, except there are layers of fuel in place of a hollow framework. The advantage of a pyramid fire is that it burns for a long period of time, resulting in a large bed of coals. This fire can possibly be used as an overnight fire when placed in front of a shelter opening. The star fire is used when conservation of fuel is necessary or a small fire is desired. It burns at the center of the wheel and must be constantly tended. Hardwood fuels work best with this type of fire. Thank you for watching.